So for your do now today, I'd like you to go ahead and divide the problem you see right here using long division. So it's already set up for you to go straight into the division. Try it out, pause the video, and see if you match me on your solution. Going to work it out myself here, you would put a 5x up top, and then you would distribute the 5x to both parts here. After you distribute, you subtract negative 18 minus negative 20, turns it into a positive 2x right here. We bring down our next term of negative 19, and the cycle starts over. X times a 2 is a 2x, so that goes up top. You put 2x, you have a minus 8, and when you subtract these two things, you get a negative 11 for your remainder. So what we do with our remainder is we put either a minus or a plus sign here, and then we had 11 over the x minus 4 for the end of our solution. So this procedure right here is known as long division. I really like long division because it relates to math that I learned back in elementary school, and I already sort of understand this structure pretty well because of it. Today, what I'm going to do is teach you a different way to do the same exact problem using a procedure called synthetic division. Synthetic division and long division accomplish the same goal. One method isn't necessarily better than the other. It's not like you need to know both of them in theory. So there's a lot of times in this class where I make you learn every single method because there's different reasons to learn each one. These are just two different methods for doing the exact same thing. So what I need you to do in this video is hear me out, learn how to do it, and make a decision for yourself which method you personally like better after you've tried both of them out. Okay? I would say it's usually pretty split, 50-50, in terms of who likes long division and who likes synthetic division. So you'll just got to kind of watch the video, see what you think, and pick the method you like better. So with that kind of out of the way, here are the steps I want you guys to write down for synthetic division. And a little comment I'm going to make on the side of this right here is that synthetic division is just a different way or a different method to divide. It's just an alternative to long division. And these rules right here are fine. I will explain them. It's kind of just easier to jump into the problem, I think. So I'll explain those rules as they come up in this example. I'm going to start by doing the exact same problem I just did. Rule number 1 with synthetic division says to use the root and not the factor. The factor in the problem I just did is going to be the thing you divided by right here, which is the x minus 4. So if I have an x minus 4 here, I do not want to put x minus 4 on the outside. Instead, I'm going to solve it by setting it equal to 0 and finding my solution. So I'm going to get the number 4. That is what I use for synthetic division. You use the root, not the whole parenthesis that it came from. So what I'm going to do, synthetic division involves putting just the number on the outside, and I'm going to put it's a weird looking upside down division box like this, big enough for 2 rows of numbers. So 4 goes up here, empty box with 2 rows. Rule number 2 for synthetic division is that we only need the coefficients. We don't have to worry about our variables when we do the problem. So my coefficients on the inside were a positive 5, a negative 18, and a negative 19. So these problems look kind of odd when you do synthetic division here. I've got my numbers on the inside without variables, and I've got my roots on the outside. The final rule, and the reason why people I think like synthetic division better, says that you should use addition instead of subtraction. So let me show you how this process works. You always start by bringing down your very first number all the way to the outside of the box, which is where your answer is going to go. So that 5 just pops all the way down here to there. Then what you do is you take your outside number and you multiply it to the 5, and you put that in the next slot on the inside. So 4 times 5 is 20. So I put a 20 on the inside. After I put that 20 on the inside, I have to add these numbers together, not subtract. A negative 18 plus a 20 is a positive 2. The reason I'm allowed to add and not subtract is before it was an x minus 4, and here it's a positive 4. So I've already kind of reversed my sign going from here to here. That lets me add instead, which is good because addition is easier than subtraction usually. Then the process just keeps going. After you put a number on the bottom, I'm going to do 4 times 2, which is 8. Negative 19 and 8 is a negative 11. So you can look at this guy right here, and you can look at the answer up here that I got from long division, and you should be able to see the similarities there. The way that it works is you start actually on the right side, and you read this guy backwards. The farthest over number is your remainder. So I'm going to have negative 11 over, and you don't put the 4, you put the original factor there. So it's going to go negative 11, x minus 4. So this guy, I box him off, he's the remainder. This guy is your plane number. This guy is your linear term. If I had another number right here, that would be my x squared, etc. So this is constants. This is x. This guy would be x squared, etc., etc. So what this is going to look like then is I'm going to have a plane number of 2, and then I'm going to have a linear term of 5x. So you get 5x plus 2 and negative 11 over x minus 4, exact same answer. Like I said, one method isn't better than the other. It's totally a matter of personal preference on this, whichever one you like. So you're going to have to practice it my way, the synthetic division way, for a while in this video. And then for tests and stuff like that, you just choose whichever method you like better. Takes a little getting used to here, but there are a couple of reasons people like it better. Personally, I like long division better because I like just seeing everything. I'm just comfortable with this, but this tends to be faster. Synthetic division tends to be faster and a little easier on you once you have it set up. So let's get some practice with synthetic division. Let's go ahead and start by finding the roots on the bottom. That is what you need to put on the outside. If you see an x plus 6, that means the outside of my division box is going to say a negative 6. It's always going to be the root. So I put a negative 6. I get my division box going right here. My inside goes 7, 39, negative 30, negative 50. First term always gets carried down all the way to the bottom. Then I multiply negative 6 times 7, which is negative 42. I would add those together, which is negative 3. Multiply, I get positive 18. Add, I get negative 12. Multiply, I get 72. Add, I get 22. So these numbers here on the bottom are my answer, but I have to decode this and put it back in like x terms. The far guy is your remainder. So my remainder is a 22. This is my plane number. This is my x. This is my x squared. If I had another one, this would be x to the third. So my answer to this problem is 7x squared minus 3x minus 12 with a 22 over the thing I divided by, which was x plus 6. So as you can see, the nice thing about synthetic division is it takes less space. This would have taken me almost a full page of work to do the long division way. Long division is definitely longer to write out. It also goes pretty fast once you get used to it. So some of you that may appeal to, some of you will just like long division better, and either way is fine. If you're starting to feel like you might want to do synthetic division, there are 2 tricky things you have to watch out for. Let's go ahead and look at this next example here. When I go to make my division box, my outside is going to say a negative 2. And then on my inside, I'm going to have 8x squared plus, there is no middle guy right here, so you have to put a 0 in the middle. Here's one thing you have to watch out for if you're going to do synthetic division. With long division, you would catch your mistake if you forgot your 0 because stuff doesn't line up right, like I showed you in the last video. With synthetic division, if you just went like this, 8 and 3, you would never know you messed up, okay? Because there's no like x's or whatever that aren't going to match up correctly. So you need to make extra certain when you do synthetic division that you remember your zeros. Write that as another note for yourself here. Remember zeros for missing terms. If you forget, you will not catch your mistake. So be careful there. Once you remember the 0, it's really not bad. You just put your 8 down. It's a negative 16. Add those, I get negative 16. That's 32. This will be 35. Remainder, plain number, linear. So my answer is 8x minus 16 with a 35 over x plus 2. So that is one thing that you have to keep in mind, is just remembering zeros for missing pieces. Let's go ahead and talk about this next example right here. Now, the first thing I'm going to do with this problem is I am actually going to write this out with long division. You'll see why in a minute, but I'm going to pop that up here in just a sec. You don't have to do it yourself. I just want it up here to illustrate something. All right, so here's the solution to this problem with long division. Let's go ahead and jump in with synthetic division. Your first job is always to find the roots for the bottom. Well, if you have a 3x plus 4 in the bottom and you equal that to 0, you're going to solve for x and you're going to get negative 4 over 3. So it's a little unfortunate, but you do need to use the fraction. I guess you could go decimal, but this decimal repeats, so fractions are just better in general. With this, that is what's going to go on the outside. You got to set up the inside just like normal. The 9 comes on down to the bottom. Then I need to do negative 4 over 3 times 9. And when you multiply that out, negative 4 over 3 times 9, I actually find it easier to do the division part first. I'm going to do 9 divided by 3 and then times negative 4. It'll get you the same answer, but that should end up being a negative 12 when you set that up. Then I'm going to add these two things. When I add those two things, let's see, I have negative 3 and I have negative 12. Those are going to make a negative 15. One more time here, I do negative 4 over 3 times negative 15. That's going to make a negative 5 when I do the divide part, and then negative 5 times negative 4 is going to be a positive 20. When I add those one more time, I'm going to get 13 for my last number. Now, the reason I worked this problem out both ways is if you look at the long division answer, and if you look at my synthetic division answer, these do not match, just like the other ones did. The other ones did match. This one did not. The reason that these are not the same is because of what we divided by. When you put a negative 4 over 3, and that's what you divide by, I kind of picture synthetic division like a little machine. It doesn't know that this negative 4 over 3 was actually a 3x plus 4. It thinks you divided by x plus 4 over 3. So it just takes this and flips the sign, and that's what it believes that you divided by when you did your problem. So if you are going to use synthetic division, after you do your division, when there's a number in front of x, you need to divide each of your coefficients by that number, but not the remainder. Right now, the remainder would technically be over x plus 4 over 3. We're going to rewrite it so it's over what it's supposed to be right here. So this is probably a tiny bit confusing. It's really not that bad. Just when you do your division, if there's a number in front of x, divide your coefficients by that number. I'm going to end up getting 3x. I'm going to get a negative 5. And the 13 stays the same. You don't divide that part, but you switch it to over the 3x plus 4. If you do that, you will get the same answer that we got through long division. Okay, so let's write that down somewhere as a note for ourselves here. Remember to divide by the number in front of x in your denominator. So if you see a number in front of x right there, you have to divide by that number. We'll practice that one more time. It's not as complicated as it seems. It's just one thing to remember here. So let's go ahead and look at this last problem for the video. Second to last, actually. Sorry, I got one more thing after this. So this second to last problem right here says that this parenthesis is a factor of this equation. When you see that, that tells you when you divide, it goes in evenly. We did one like this in the last video. So this time, we're going to use synthetic division. And in order to use synthetic division, the first thing I do is I solve that guy. I equal it to 0. If you equal that to 0, you're going to get a half. That is your roots. Then on the inside, I'm going to put my different coefficients here, just like that. And I'm going to do regular synthetic division like you guys should be getting used to now. So when you multiply all this out, you do get a remainder of 0 like you're supposed to. But this is not a final answer yet because I had a 2 on my x right here. If I actually divide this, I'm going to get 1, 6, 5. Or in other words, that's a 1x squared plus 6x plus 5 with a remainder of 0. So when you divide, we divided a 2x minus 1 into this guy, and we got this answer right here. What that tells us is that our original problem, this red guy right here, is going to factor into thing we divided by times answer we got from division. If you were to FOIL these, they would get you back to this blue problem. So now I just need to solve these and get my answers. If you do magic numbers on the right quadratic, you'll get those two parentheses. So then it's easy to solve. You're going to get 1/2, you're going to get -3, and you're going to get -2. So I got all three solutions to my x to the third problem. One thing that didn't pop up in this problem, but I could do instead of saying like, oh guys, 2x minus 1 is a factor, I could tell you an answer to the problem. So if I know, like, let's say I told you, oh guys, x equals -3 is an answer to this problem. What you can do then is you would just use the -3 straight up because you use the answer in synthetic division. If you were going to do this with long division, you would turn this to x plus 3 and you can divide by that. So instead of giving you the factor, they may give you the answer. And then you either use the answer with synthetic or use the parenthesis with long division. There's one other thing really quick that I want to show you guys here. It's just kind of a consequence of synthetic division. It's more interesting than actually useful. But what this theorem says is that if you want to plug a number in for x to an equation, so say I wanted to plug a 5 in. 5 isn't even that hard to plug in. We can do that just by hand right here. If you were to plug in a 5 to this equation, and you do your math on this, that's going to be 25 times 2 is 50. 50 plus 30 plus 10 is 90. So the answer, when you plug in a 5, is a 90. This theorem says if you take the number you want to plug in, and instead of just plugging it in like a normal person, you wanted to do synthetic division with that number. What will end up happening if you go through and you do your steps right here is the remainder that you get is the actual number you would get if you plugged it in. So if you had a problem like this and you did the little division here, my remainder 90 tells me I would get a 90 if I plug a 5 in. This is like almost pointless in terms of like application and being useful in today's world because I have a calculator. I did this by hand right here. And if it was a big number, I have a calculator that can do it for me. This theorem used to be a big deal though, because if I had like x to the 5th and x to the 6th, then back in the days before calculators could do really big powers, this was a good option that just involves multiplication and addition. So just more of a quirky little theorem here. The remainder that you get is what you would get if you plugged in that number. So that is synthetic division. And like I said, for the homework over this lesson, you got to use synthetic division. But then you can pick the one that you like better between synthetic and long. I will not make you use both methods on a quiz or test. You just pick the one you like better.